Okay, our last lesson in this whole rational expression unit is going to be given a rational equation. We would like you to solve for x. Now this is where it's going to be a little bit tricky. Okay. Our goal here is to, looking at this equation, we have three different fractions. We have one here, we have one here, and we have one here. If we can eliminate all of the denominators of each one of those fractions, I would then be left with just something that has no fractions. Okay, and the way we do that, and there's actually a way we can do that, and the way is if we multiply this fraction, and this fraction. If we multiply all of those by the LCM of the denominators, okay, the least common multiple. So we're looking at 4, we're looking at 3, we're looking at 12. What is the smallest number that all three of those numbers can divide into evenly? And if you notice, 12 would be that number. And there's a way using prime factorizations to figure that out. I think most students can kind of just look and see that this is the LCM of 4, 3, and 12. If you want me to show you how to do that, you're welcome to leave a question or comment, and I can make a video on how you would calculate that this is the LCM of all three of those. This is something we've done, though, a long time ago in math. Okay, so our LCM is 12. Now, the reason we're going to do that is because each one of these numbers, the 4, the 3, and the 12, if I multiply all of the numerators by 12, this is what we're going to get. We're going to get 12 times x. We're going to multiply these two, and that would give me 12x over 4. And we could multiply these two, and that would give me 24 over 3. And by the same token, we can multiply this. I'm not actually going to multiply. I'm just going to write it as a distributive property problem, and I'll tell you why here in a minute. Okay. Now notice, if I divide those two things, what's 12 divided by 4? That's just 3. Notice that the fraction is gone. And if I do the same thing here, I'll get 24 divided by 3, that's 8. Again, fraction gone. And the reason I'm not going to distribute the 12 is because the 12s are going to cancel out. And I would just be left with 2x plus 7. And at this point, I could then just solve like we have in the past. Now that fractions are gone, this is now just a simple linear equation that I can solve just by adding and subtracting stuff on both sides. So the way I would do this is I would subtract 2x on both sides, and then I would get, that becomes a 1x, or just x. And then I have plus 8, that didn't change. That became 0, and then I have 7 on the right side. Now let's take this remaining equation. Let's get some more room here. And so we have 1x plus 8 equals 7, or just x plus 8 equals 7. And then simply from here, we can subtract 8 on both sides, and we can get x equals -1. And then that would be my answer. Now one thing you have to make sure in all of these is you got to go back and look and see if I plug x into this original equation I started with, are there any problems that arise? Now this is only going to happen if you have an x on the denominator, which in this problem I don't have an x, they're all just numbers. But if you look at the next example, we will have a x in the denominator. So that's might throw some challenges at us. But the same thing is going to happen. We're going to try and find the LCM of all of the denominator. Okay? And so what we're going to do is we're going to say, okay, let's take a look at these two things right here. What is the LCM between 2 and 10? And that LCM would be the smallest number that 10 and 2 can divide into. And if you think about that, that number is going to be 10. Okay, the LCM just between those two things is 10. Okay, now what I want to do is this x plus 3 is kind of its own deal. All right, so that also needs to be part of our LCM. Because remember, when I multiply all of the numerators by this LCM, I want the denominators to cancel out with at least one piece of the LCM. It doesn't have to cancel out with all of it, just one piece of it. Okay, so let's take a look here. So we're going to have, I'm going to spread this out. We have 2 and x plus 3, and we're going to multiply that by my LCM. And then we have 3 over 2. I'm going to multiply that by my LCM. And then we have 19 over 10. And the reason I can do this is because I have an equation. As long as I do that multiplication to both sides of the equal sign, it's legitimately okay to do mathematically. Okay. Now I'm going to take each individual each individual fraction, and I'm going to cancel anything out on top and bottom that I can. Remember, this x plus 3 is now on top of that fraction, and so I can cancel it with the x plus 3 on the bottom. And so what I have left over is 2 times 10. Okay, plus. Now, I can't necessarily cancel out the 2 with anything exactly, but I can kind of reduce this 10 on top and the 2 on bottom. I can make that into a 1, and I can make that into a 5. And then I have 3 times 5, parentheses, x plus 3. And we're going to repeat that process over here. We have the equal sign now. Let's bring that down. We're just kind of bringing our signs down, bringing our equal signs down. And on this last one, the 10 on top and the 10 on bottom are going to cancel out as well. And all I have is 19, parentheses, x plus 3. Okay, let's do a little simplifying now. 2 times 10, that's 20. Then I have 5 times 3 on the outside of that parentheses, and that's just 15. And then I have this right side that doesn't need to change at all. All right, now, we're running out of room, so let's go to a new page. Okay, from this point, we're just going to solve the equation. We've done stuff like this in the past. Let's solve now. So the 20 is not going to change. Let's distribute the 15 to both x and the 3. That would be 15x plus 45. And over here, do the same thing. 19 and 3, 19x plus, and 19 and 3, that's what, 57? Again, we're just gonna keep going. Let's combine like terms on this left side. That would be that'd be 65 plus the 15x equals 19x plus 57. Okay. Now I think it's easiest if we just subtract 15 on both sides so that my x stays positive. If I minus the 19, then I have 15 minus 19, and that'll give me negative 4. However, if I subtract the 15, and I do that to both sides, I will get 65 is equal to 4x plus 57. Okay, now we're going to get our numbers all together. So we're going to subtract 57 on both sides. And that gives me 8 equals 4x. And at that point, you can probably see where we're going with this. Let's go 8 equals 4x. Divide both sides by 4, and you get x is equal to 2. Now, as we get our answer, let's go back to the beginning. Okay, if I plug positive 2 into here, what we're looking for is, does it create 0? If it creates 0, we have a problem because, for instance, if I were to plug in negative 3 in for x, I would get negative 3 plus 3, and that would give me 0. And then I would have 2 divided by 0. And that's an undefined number, which in that case, we would say that the answer we got of negative 3 does not work because it produces an undefined result. However, we don't have negative 3. So if we look at our answer of 2 over x plus 3 plus 3 halves, and I'm just kind of checking my answer. So we got x equals 2. Let's plug 2 in for x. So we'd have 2 over 2 plus 3 halves equals 19 over 10. Okay. Now, it doesn't produce a problem because that right there is not 0 after I plug x in. This is 2/5. That does not create a problem. It is possible, however, to get an answer and have it so where if you plug it in, it produces a 0 on bottom, and then that becomes a problem. Now, if we add these two fractions together, just use your calculator, you would get, you should get 19/10. And that does check out as an answer, and we know that we got the right answer. So I realize this is kind of hard. I'm going to do some more difficult ones in another video. So have any questions, let me know. Again, this is hard stuff, so I expect questions. I can post problems and things or an extra video if needs be to maybe clarify some problems. But anyway, thanks.